Hello everyone, welcome to another informative video from Surveying and Mapping, or SAM. In this video we're going to be talking about geodatabases. What are they? How do they work? And what can you do with them? Geodatabases were developed by Esri in the late 90s and early 2000s for use with their new platform called ArcGIS. This included ArcGIS Desktop, which also included ArcMap and ArcCatalog and ArcScene and ArcGlobe, as well as ArcGIS Server. Later, they added ArcGIS Online and ArcGIS mobile apps such as Collector to this platform. Since its release in 1999, the ArcGIS platform has used the geodatabase as its primary storage format. And as it has grown and evolved, so has the geodatabase. Unlike other GIS formats such as the shapefile, a single geodatabase can store a wealth of different types of data. You can store raster, you can store vector, you can store standalone database tables all in a single geodatabase. And that's not all. You can also store LiDAR point clouds in there, toolboxes with automated tools, data behavior, and so on, which really makes the geodatabase a very powerful format and allows you to make it a single storage container for all of your GIS, which then makes it easier to manage and give access to. Now, the geodatabase comes in multiple types, including file, personal, enterprise, and mobile. Each one of these types is designed for different use cases, and you can mix and match because the architecture of these are the same or very similar, which allows you to connect these different databases together so you can replicate data back and forth between them depending on your use case. So let's take a look at one really quick, and then we'll get in and talk about how they're organized. So here we are in ArcGIS Pro. And over here in the catalog pane, you can see I have a geodatabase connected called trippville_gis.gdb. This happens to be a file geodatabase. When I expand it out, you can see the contents that are included within this database. You can see various feature classes. So I have a multi-patch feature class, a polygon feature class, point feature class, line feature class. You can also see a raster file here. This digital elevation model, or DIM, is in here. We have a standalone table with this crimes 2014 table included in this geodatabase. And then down here, I've got several tools, or I should say a toolbox, and inside that toolbox, I have several tools, some Python scripts and some models created with Model Builder that I can use within my GIS to do different functions, different analysis and things depending on what the tool is set up for. So within this single geodatabase, I've got several data types stored within it. I also have it broken down into featured data sets, which we'll talk about more in just a little bit. So you can see those in there as well. So within this geodatabase, I've got a lot of information, a lot more that I could put into a shapefile or a KML or a KMZ or even an AutoCAD DWG or a MicroStation DGN file. This is why geodatabases are the preferred format for ArcGIS, because they can store so much information in a single location. And again, this just makes it so much easier to manage. I'm not looking for different folders with different files in them to see who has access to them, where they're at on my network, and those kind of things. They're all sitting right here. This makes it so much easier to work with. So let's go in and talk a little bit about organization within a geodatabase. So regardless of the type of geodatabase you're using, whether it's a file geodatabase or an enterprise geodatabase or a mobile geodatabase, they all share a common organizational structure or concept there. At the very base level of that is something called a feature class. And a feature class, which you've already heard me use that term in this video, is just a collection of data or features that share some common parameters. They're going to have the same geometry type, meaning they're all going to be points, they're all going to be lines, they're all going to be polygons, they're all going to be multi-patch, they're all going to be annotation. So they're all going to share that type of geometry. So when you create the feature class, you'll decide what it's going to store, which makes a feature class a type of vector data. very similar to what we talked about with shapefiles. They're also going to share a common attribute table, that data table that's linked to those features that have additional descriptive information. Right? If you're talking about roads, it might have the road name, road type, address, minimum and maximum values on it, pavement type, those kind of things, right? So you're going to have that attribute table tied into that feature class. And then lastly, they're going to share a common coordinate system or spatial reference. So all of the features in that feature class are going to be located using that common coordinate system, and that could be something like Universe Trans Mercator, UTM, Web Mercator Auxiliary Sphere, WGS 84, latitude and longitude, whatever coordinate system that is that's assigned to that feature class. All of the features stored in it are going to use that. Okay? So you can create these feature classes in the geodatabase, either at the root of the database, and I'll show you what that is in a second, or within something called a feature data set. So a feature data set can be thought of kind of like a folder in your geodatabase. It's a little bit more than that. It has some extra behavior and things that go along with it. But really it is a way to group related feature classes. In this example on the slide, you can see that I have 3 feature data sets. I have a base, a sewer, and a water. So anything that's related to what I would think of as base layers, so parcels, roads, city limits, county boundaries, those kind of things would be in that base feature data set. Anything related to the sanitary sewer system would be in the sewer feature data set. And the same would go with the water system and the water feature data set. Now, what is special about a feature data set, besides the fact that it's an organizational container within your geodatabase, is that every feature class you put inside of a feature data set is automatically going to inherit the spatial reference or coordinate system that is assigned to that feature data set when you create it. So anytime I generate a new feature class within that feature data set, so for example in the sewer feature data set, if I were to add a new feature class called lift stations, I wouldn't have to assign the new lift station feature class a coordinate system. It would automatically inherit that from the sewer feature data set. And that's important because then I can add behavior to the feature classes that are part of that feature data set. And we'll talk a little bit more about behavior in just a little bit. But let's go back into ArcPro and take a look at the geodatabase and some of these feature classes and some of the feature data sets within it so you can get a better idea of what I'm talking about. So here we are back in ArcPro, and we're back at our Trippville GIS Geodatabase. Now I mentioned that you could store feature classes at the root of the database. And by that I mean like the ones you see here. They're not in a feature data set. They're right here at the beginning of the tree for the geodatabase. So here's the census block group, census tracts, crime location feature classes. All of these are at what we call the root of that geodatabase. They're not within a feature data set. And when we look at a feature class, so let's just pick one here, light poles, for example. If we go into the properties of that feature class, you can see a couple things. It's going to show the source of that feature class. We see the type. It's a simple type. It's a point feature class, as I was talking about earlier. So you can see I've got the extents in here as well. So this is the minimum and maximum X and Y value for features that are stored in this feature class. In this case, we can also see the units, feet US, so it's US survey feet. If I go down, I can expand the spatial reference. So again, the coordinate system associated with this feature class. So all of the features that I see in the light pole feature class are going to be in NAD, which stands for North American Datum, 1983, State Plane, Georgia, West, FIPS, and so on. So this is going to be the coordinate system. It's a Trans-Mercator coordinate system. And again, the rest of the properties that are associated with that coordinate system. So you can see that all of these properties are part of that feature class. And then if I add that data, so I'm just going to add this to my map by dragging and dropping it in. And I'll turn off the other layers that were already in there. So now you can see down here the light poles. And with that, if I right click, I can open the attribute table. So this is the attribute table that's associated with light poles. Now this particular table has very little information in it. It's a very rudimentary table. But if I were to go to, say, the manholes that we had on earlier and open its attribute table, you can see it has a lot more information in it. And what this helps to do is highlight that attribute tables are very customizable. You can choose which fields or columns are in that table and what data is critical to you in how you want to use your GIS. So again, this just gives you some example of the way the attribute tables work. But you can see now with that single feature class that we have everything in there's the same type of data. It's all point data, it's all line data, so forth, so on. You've seen the attribute table, and you've seen the spatial reference that goes along with it. And again, if I click on, or I select, let me go back and choose my select tool up here and make sure I have the right layer set as selectable. Let's just leave manholes as selectable, right? So when I click on this manhole, you'll see it says 1 of 541 are selected. And if I show only selected records, you can see that this spatial feature, this particular sewer manhole, is linked to this record or this row in the attribute table. Again, highlighting the relationship between the geometry and the attribute table within the feature class. So let's go look at the feature data set and see how this is a little bit different. So we'll close this out. We go back over here to our database, and we can see the different feature data sets. They're symbolized by these kind of 3 stacked boxes that are slightly offset from each other. That's the icon for a feature data set. And this kind of gray cylinder, white cylinder, is a symbol for a geodatabase. Okay? So within here, you can see I have multiple feature classes within this base feature data set. Again, things that would often be associated with kind of base map layers or layers that help put other information into context, both spatially as well as within attributes. So I've got buildings, which would be building footprints, city limits, county limits. I've got a map index for printing map books in there. Streams, bodies of water, lakes, ponds, those kind of things. Parcel data, right? Again, all of these are in here. And again, I can add them to the map simply by drag and dropping them. But if I look at the properties of the feature data set, you can see, again, simpler than a feature class, but it tells me what the name of it is, how is it storing its coordinates, in this case with high precision, and then, again, a spatial reference. So everything stored in this feature data set is going to be, again, in this NAD 1983 State Plane, Georgia coordinate system. And I can verify that by going to any of these other feature classes that are in here. And again, if I scroll down to the spatial reference here, you can see that that matches up. In any new feature class I create, so I'm going to go here and go new and do a feature class. And for this purpose, I'm just going to call it Tripp Poly for Tripp Polygons. I'll leave it as polygons. And I'm going to go next. And then any sort of fields I want to put in the attribute table, I could define here. Go next. But notice it automatically has the coordinate system assigned here. I don't have to do that because it picked it up from the feature data set. And I'll just click Finish. Okay? So there is my Tripp Poly feature class that I just created in that feature data set. Again, I didn't have to define any of these coordinate system parameters because it picked that up. It inherited it from the feature data set. Again, making it very easy to manage data and ensuring that everything in there is related. And this, again, becomes important with the topic we're about to discuss, which is behavior. There are certain spatial behaviors you can apply to data that's in a geodatabase that allows you to reduce errors, find errors, and so on. But to ensure that functions properly, you need to make sure the data is all in a singular coordinate system. So this is where a feature data set really comes in handy to allow that type of functionality that we have in a geodatabase. So let's jump over and talk about some of the behaviors that we can use inside of a geodatabase. So one of the real powerful capabilities of a geodatabase, aside from being able to store multiple data types all together, is the ability to apply behaviors to your GIS data. The old adage, garbage in equals garbage out, is definitely applicable to GIS. So we want to make sure any data that we're using to do analysis, to visualize, to share, whatever it is we're doing, is as clean as it possibly can be. And this is where behavioral rules are important. And the geodatabase supports a lot of different types of behavior to help ensure your data is as clean as it possibly can be. So this is unique because we don't see this in other types of GIS data. For example, shapefiles, KMLs, DWGs, DGNs. None of these support behavior internal to the format itself. Now, you can programmatically put behavior to the data within an application, but it's not native to the data itself. With a geodatabase, the behaviors we're talking about are actually built into the database itself, meaning they're running anytime you're accessing the data, updating the data, doing analysis on the data. That capability is just inherently there in the background. And you don't have to worry necessarily about it being dealt with programmatically, which is a very powerful capability. Now, we can look at some of the behaviors depending on the type of data that they impact, I guess is a good way of putting that. So first, obviously, spatial data. Very critical to GIS, those points, those lines, those polygons, and so on that we see in the map. We want to make sure that data is as clean as possible. Is it properly connected in there? So there's several different ways that we can assign behavior to spatial data in order to validate its accuracy, its completeness. One of these, which is kind of at the core, is something called a topology. A topology is that basic behavior that models how our features are related to one another spatially. Are they coincident with one another, meaning are they on top of one another? Are they adjacent or beside one another? Are they within or do they overlap one another? These are all different spatial relationships that we want to be able to validate and make sure that the features we're looking at are indeed where they're supposed to be. For example, is a sewer manhole connected to a sewer line and vice versa? So we can do this with a topology in a geodatabase. It allows us to assign rules to our spatial data so that we can validate how they are related, right? Again, I mentioned, is the sewer manhole connected to the end of a sewer line? But we can expand that and look at other things like, do parcels overlap? Land parcels shouldn't overlap. People get upset when the property they own overlaps their neighbor's property. That just shouldn't happen, right? So there's a whole list of rules that we can apply to data to make sure that we have the proper spatial relationships. And Esri actually has a poster for that. So here you see the poster for geodatabase topology rules, and you can see they've been broken down whether they apply to polygons or to points or to lines or multiple. So this is a list of all the rules, and I'll zoom in here quickly just so you can kind of begin to see some of these, right? So polygons must not overlap. That's what I was talking about with the parcels. Must contain a point. So within each parcel polygon, there should be, for example, an address point, right? We see some other things with boundaries must be covered by. So All parcel polygons must have their boundary covered by a property line. Okay? We must not have lines that have dangles, meaning they must connect to something else. For example, and again, you can see this list of rules. And I'll put a link down in the video description for this poster so that you can download it and see these rules for yourself. But this is, again, a very powerful tool for validating your spatial data to make sure that things are where they're supposed to be in relation to other things within your GIS. Okay? And then this serves as a basis for the other rules, or I should say the other behaviors that I'm about to talk about. So building on that concept of topology are other behaviors that are used within networks, usually associated with utilities, although they could be applied potentially to transportation networks, but we're looking at things like geometric networks or trace networks. So these are, again, building on that topology concept, but really focused on those linear networks, making sure the right connectivity is there. But in addition to having those checks for the data, there are also tools built into those that allow you to do traces. So for example, if I'm looking at a water system, if I shut off a valve here, what does that do to the rest of the network? So in the older versions of Esri software, ArcMap, and so on, we did that with something called a geometric network. And that is being phased out with the introduction of ArcGIS Pro and ArcGIS Enterprise and ArcGIS Online for things like trace networks in the utility network, which we'll talk about in a minute. But that trace network is very similar to, in general concept, to the older geometric network. All of these, whether it's a topology, a geometric network, or a trace network, can be built inside of a geodatabase, but they have to exist inside of a featured data set. Because again, we're looking at the spatial data and the relationships between the data. So to do that effectively and efficiently, we need all of that data in the same coordinate system, which, as we have seen, a featured data set does that. Now, the other component to GIS data is that tabular data, those attributes. And so we want to make sure that data is just as clean and just as accurate as the spatial information. So again, there's different behavior we can build into the geodatabase that helps us improve the overall quality of the attributes that we're putting into our GIS. Kind of at the base level of that, we have something called domains, and there are two types of domains we can create. We have something called a coded values domain or a range domain. A coded values domain you can think of as a pick list. This is the acceptable values that my users can choose from when entering in a specific attribute. A range domain is simply a minimum and maximum number value that can be entered into a field. Again, that has to be a numeric field for obvious reasons, but I can't enter anything outside of that minimum and maximum value. You can kind of see an example of a coded values domain here on the slide. We're talking about pipe materials. So what type of materials can pipes be, whether it's for a sewer line or sewer system, water system, stormwater, natural gas, whatever, that's that pick list. No one can pick anything that's not on that list. That's what we're talking about with a domain there. Now, something new that's available with ArcGIS Pro and again ArcGIS Online, ArcGIS Enterprise was not available at the core for older ArcMap, ArcCatalog, those things, is something called attribute rules. So attribute rules allow you to apply an expression or an equation to your data so that you can calculate values, constrain data, or validate data so that you find errors in it. This is somewhat similar in concept to what you do in a spreadsheet, right? You can calculate different values into cells or create lookup tables and things like that within a spreadsheet. And attribute rules you can kind of think of in a very similar fashion, except it's not just tabular data, but it also can be applied to spatial data. This will help you automate the population of values into the table, checking that data to ensure any entries or updates that you do don't violate your data requirements for accuracy and quality across the board. So it's a very powerful way of ensuring the overall quality of the data that's in your GIS as you're updating it and whatnot. Whereas things like topology, which this is also somewhat built around, is more a manual process. You have the topology, you've got to run a validation on the topology rules, which then locate the errors, and then you got to fix the errors. Some of this can be automated through the use of these rules, so that it either doesn't allow the data to be entered or will help you find errors within it as it's going along. And this overall increases that just overall efficiency of working with data in a geodatabase. Next is contingent values. This kind of expands on the concept of domains. It's really built around the use of domains. What contingent values do is it limits or filters acceptable values based on other values. So for example, if you're collecting utility poles, you might also have a height field along with a materials field. Well, you know that if a pole is a wooden pole, it can only be between this height and this height. So you could set up a contingent value for the height field that says if the material is wood, you can only enter in values between this lower value and this upper value. Whereas if it's a metal pole, it can be between this height, or if it's a concrete pole, it could be between this height and this height. So you're limiting the values that can go into the height field based on the material that's assigned to that pole. Again, this really helps for data accuracy and can speed up data entry as well. So very powerful tools here. Now, there's going to be some of these that can impact both spatial data and attribute data depending on how you implement them. Kind of at the base level of this is something called a subtype. And a subtype is a way of creating subcategories within a feature class or table. So again, if I'm looking at, say, roads, I could create subtypes based on whether it's a city-owned road, a county-owned road, or a nationally owned road, right? And then when I create those subcategories, I can apply different behaviors, whether that's topology rules or domains or attribute rules or contingent values based on that subtype. So it allows me to further refine the behavior I'm applying to the features that are in that subtype. Okay? So again, a refinement of how I can apply this other behavior. So I get exactly the types of information I need to, or the type of data validation I need to in there. Now, Esri's also created some specialty, I hesitate to call them data models because they're a lot more than that. But you have something called the parcel fabric and the utility network. This is a combination of data models like I was talking about, but also tools that will go in and automatically use some of this behavior geared towards specific things. So in the case of the parcel fabric, we're talking about land parcels and how we maintain, update, analyze those parcels to ensure that data is as clean as possible. And then we also have the utility network, again, as the name would imply, that is geared specifically to utilities, be that water, sewer, natural gas, telco, electrical, those utilities. Again, it's a data model that's coupled with a series of tools that are used to better maintain that data. So again, you maintain the proper connectivity within the network, which is all extremely important if you're going to be using that data to do things like outage management, asset management, network traces, things of that nature. And again, the same true with the parcels. We want to make sure that that data is as clean as possible. And these growths or more advanced functions, the parcel fabric and utility network, are going to work both on the spatial data and the tabular data, and are really just a very advanced function capability that is only available in the geodatabase. So very important concepts here when you're working with the behavior inside of a geodatabase. And like I said, just remember, garbage in equals garbage out. So there you have it. That's what a geodatabase is in a nutshell. Obviously, this is a very high-level overview of a very complicated topic. So if you would like to learn more, or there's anything specific I mentioned that you'd like to see another video on, please make sure to leave a comment below. If you have any questions about this topic or any other thing that we've talked about in other videos, again, also please leave a comment below. I'll try to respond as quickly as I can. Also, feel free to shoot me an email if you would like. My contact information is here on the screen. So with that, I hope you got a better understanding of what a geodatabase is and how they can be used. I really appreciate you watching, and thank you for your continued support.